Knowledge in crisis.
The podcast.
Hello, and welcome to the Knowledge in Crisis podcast. I'm Audrey Powers. I'm a postdoctoral researcher in philosophy at the University of Vienna, and I'm joined today by Tim Crane and Simon Rippon for a conversation on artificial general intelligence. Tim and Simon, can I ask you to introduce yourselves?
Thanks, Audrey. I'm Tim Crane. I am Professor of Philosophy at CEU here in Vienna, and I'm also the Director of Research for the Knowledge in Crisis project.
Hello, I'm Simon Rippon. I'm Associate Professor in Philosophy here at CEU. I mainly work on ethics and theory of knowledge and other kinds of thinking about reasons.
To start out, let's just talk about, what is AGI? What is artificial general intelligence? How does it differ from regular old artificial intelligence that we've spent a long time hearing about? Why is there all this talk about AGI right now?
Let's start with artificial intelligence. Artificial intelligence is the attempt to create machines, in particular computers, that would perform tasks which would require intelligence if done by humans. That's a sort of standard definition. Sometimes people define artificial intelligence or AI as the science of thinking machines. That's going beyond what we really need to say. What it's about is creating computers that will perform tasks that would require intelligence if performed by humans. Now, artificial general intelligence is something else. All artificial intelligence programs so far have been designed to perform a specific task, say to write text or recognize faces or create pictures or play chess and so on. General intelligence is supposed to go beyond this. General intelligence is supposed to be the kind of intelligence that we have, that we can turn our intelligence to any project that we have. And it's not specified in terms of some specific limited task, but rather is a capacity that we have which we can apply to anything.
When I think about the capacities that we have, I think, people will often do things that we take to be not very intelligent, right? Individual people will do silly things all the time. When you're thinking about an artificial agent with artificial general intelligence, would it behave like a person in that way? Would it do things we think are stupid, or would it always perform at the sort of maximum human limit of a particular task? What would the actions of this kind of thing look like?
Well, that's a really good question. And I think we have to then distinguish between an AI which replicated all aspects of human behavior, even the stupid bits, and one which just tried to replicate general intelligence, the intelligence that we have. But as you say, we can have general intelligence, but also have general stupidity.
There's a question, isn't there, about when we'll have reached artificial general intelligence. I think a helpful way to think of it is an artificial general intelligence will be able to perform all kinds of cognitive tasks as well as a normal human can. So think of it as a capacity that could be exercised or not. Humans don't always exercise their intelligence capacities successfully, but it would be a range of subcapacities, right? So we can think of cognitive tasks that computers can now do well, like playing chess or doing arithmetic, or translating between languages, and other cognitive tasks that they're perhaps not very good at the moment but might be good at in the future, like deciding how to load a dishwasher the best way or to use common sense to visually interpret an unfamiliar scene. Once we've got a computer that can do all those things, as well as a normal human can, we should say it's a general intelligence.
Yes, I think that definition is actually useful. That's pretty much corresponds to how Shane Legg from Google defines artificial general intelligence, AGI. He says that AGI is the ability to perform at a range of cognitive tasks at a level which is the same as human beings or better. But what I'd like to point out about this is that that's a bit of a step back from the idea that this is something radically different from what AI is doing now. So a lot of AI has been based on this idea that we're trying to achieve or reach this moment of artificial general intelligence, which then some AI thinkers will also lead to a further development, which is superintelligence. This is the title of a book by the philosopher Nick Bostrom from 10 years ago or so, where Bostrom said that artificial intelligence could easily develop to a point where we had an intelligence that was so much greater than human intelligence. Before we got to that, we would have to get to AGI. Now, I don't think that you could design a machine to have AGI. That couldn't be a single computational project. Now, I have an argument for that.
I'll ask you about that argument in a second, but before that, to go back for a moment, neither of you think that artificial general intelligence, as we've defined it, exists at this moment. Do any of the things that we interact with that might sort of seem like this, like ChatGPT or various large language models, these things are or aren't artificially generally intelligent?
I think they're not.
I agree. So artificial intelligence at the moment is what they call a jagged intelligence. It's very good in some respects. ChatGPT is very impressive in certain respects, but also fails dismally in ways you don't necessarily anticipate to do the task you expect it to do.
So if this doesn't exist right now, the question that seems to come up is, okay, could we make this happen, either with our current technology or with possible future technology?
So perhaps I'll go out on a limb here and I'll say that, in a sense, it's in principle impossible. And it's in this sense, which is someone couldn't go into the lab or into their office and write a computer program which would be a program for a machine that had AGI. The reason for this, I think, is that all computer programs have to be designed to perform a specific task. So the task of a chess-playing program is to play chess, is to win at chess. And that's what the machine is aiming to do. And you can see whether it's succeeded by seeing whether it's won at chess. Similarly, with face recognition software, the task is to recognize a face, which just means, in this case, to attach the correct label to a picture. So you always have to specify what the task is. If you can't specify what the task is, then you can't say whether the machine has performed well at that task. My next point is that there is no such task of general intelligence. General intelligence has no task. There's nothing that it does. There's no one thing that it does. And I conclude from that you could never build a machine which had that as its task. And so you couldn't explicitly go and build artificial general intelligence. And in fact, none of the AI companies are trying to do this because they can't. What do you think of that?
Let me take a step back, actually. So let's start by making a distinction between how traditional programming works and how AI reinforcement learning works. With traditional programming, we start with an objective. We want our program to perform some task. And in order to get our program to perform the task, we have to specify precisely exactly what the task is. We then have to break it down into discrete steps. We have to specify each step precisely, and we have to turn that step into code that we can test and run and see if the program performs the task we want it to do. With AI reinforcement learning, it's quite a different procedure. So if you think about what they call deep learning neural networks, they're inspired by the brain and they're roughly analogous to the brain. So you have inputs, you have connections in between, you have neurons, which are connections, and then you have outputs. And the inputs feed through the neurons to the outputs, and the neurons adjust their weights, their connections, if you like, to get you from inputs to the desired outputs. All right, and we train these neural networks. So how are the neural networks trained? They can be trained with human feedback. Suppose we want to design a neural network to recognize faces. We can start by inputting the faces into the neural network, and you'll get random answers at the beginning, and we give them feedback. We say that's a bad output, and marking the output as bad feeds back into the neural network. It adjusts the weights on the inside, so it's more likely to come up with the desired output for the input. And we repeat, this process is basically repeated either by the neural network itself or with human feedback an amazing number of times until eventually the network sort of adjusts itself mathematically. Our network develops the capacity to distinguish faces as we wanted it to distinguish them. Now notice that we don't have to have any very clear idea of what it is to recognize a face, or at least of how that works. This is why neural networks are kind of black boxes. It's difficult to know exactly how they're doing what they're doing. Unlike in a traditional program where we've told the computer each of the steps it must take, the computer mathematically programs itself to associate the right inputs with the right outputs. We need not know how the procedure works. What does that mean? It means that we can get computers to do tasks now that we don't know how to do exactly, or we can't define how to do, but we know what it is to do them successfully. As long as we can decide whether it's successful or not, we can give feedback to the computer and train it to do better at that task. So I agree that there's no task of general intelligence that we can train a computer to do, but of course there are tasks we can train a computer to do which exercise or demonstrate intelligence in the sense that we've just just talked about. So if we can get computers to do the tasks of using common sense to visually interpret unfamiliar scenes, for example, we would say that's intelligent cognitive behavior on the part of the neural network. So I guess I agree that there's no task of general intelligence, but I don't see a very special significance in that. As long as we can give computers feedback on tasks that are intelligent tasks, we can get computers to develop this capacity in principle.
I think this is a really good point. I agree with Simon that you can evaluate the outputs of these machines as to whether they exhibit what we would recognize as intelligence. And then if you build up enough of the different capacities, you might say, along with Shane Legg, that they've met enough of the criteria to perform well at a bunch of cognitive tasks that require intelligence in humans. You could say that that's what AGI is. In which case we've already got it. So there's a bit of a mystery why these firms like OpenAI and Google DeepMind are telling us that we're on the brink of achieving AGI when we've already achieved it. These machines can already recognize faces very effectively. They can already produce text of a higher quality than most people can produce. They can already calculate, not large language models, but traditional AI can already calculate much faster and much better than human beings can. That's why we use them to calculate. So there's a bit of a mystery here, which is, what's the big deal about AGI if AGI is just a matter of performing well at an unspecified number of tasks? I'd just like to come back, if I may, pedantically to one thing Simon said. I don't think it's relevant here how the machine actually works on the inside. That wasn't the point. The point is the output. The point is that you're trying to get the machine to do a specific thing, and you can train it on whether it's done that thing or not. And in this case, the case you mentioned is classifying faces or recognizing faces. But I don't think that's a real point of disagreement between us. I think the question is, what's the big deal about AGI if we've already achieved it?
I think that the question about what the machine looks like on the inside, though, is interesting, because when Simon was talking about how these models are trained, as a layperson, I think something like, well, that sounds not totally unlike how human beings are trained. Nobody ever sat me down and gave me a facial recognition task. But when I learned to read, I think I was given some tasks quite like that. Oh, yes, that's what sound that letter makes. These things seem very, very similar to the way that these LLMs are trained. And that does make me think, even if I don't think that ChatGPT as it currently exists seems like it has AGI, it at least makes me think there's something going on in these things that's much more like me than I might have thought.
Yeah, I think if there's one big lesson here for philosophy and also for linguistics, for example, is that linguists following Chomsky used to argue that it's impossible to get to the production of grammatical sentences without internal representation of grammatical rules. And here, now we have machines that do it. But that doesn't mean that the way that machine does it is actually the way we do it. Certainly, broadly speaking, learning from experience, of course we do that. Reinforcement learning, that's something that children do. But the way they do it is very, very different from the way we do it.
I disagree with you there, Tim. Do we know that a neural network producing grammatical sentences does it without internal representation of grammatical rules? I don't think that's something that we know.
When both of you say internal representation of grammatical rules, what exactly does that mean?
Yeah,
what would it be to have such a representation?
That's a great question.
Do we have such a thing?
We'd have to start with the idea of internal representations. So the computer model of the mind and other models of the mind say that the mind represents the world. And let's just take the brain as an example, that there are areas of the brain that represent, that is to say, stand for things in the outside world. So the visual parts of your brain take light in from the eyes and they form representations in the visual cortex at the back of your head of parts of the visual world. What does that actually mean? What is it for the brain to form a representation? That's a big question that we should have another podcast on. But that's the standard assumption among cognitive neuroscientists, that the brain forms representations. A representation of a grammatical rule would be a representation that takes input from spoken or written language and processes that in the brain in accordance with a rule that says, how words are put together to make sentences. And Chomsky is famous for arguing that these representations must be common to all languages. That's a big issue, but yes, thanks for pressing it, Audrey, because what it is to be a representation in the brain or the mind is a huge philosophical question.
Let me give you an example. So there are some grammatical rules that are well known in English. There are some that are less well known. Here's one that's maybe less well known. So if I say the red big ball bounced down the street, you would think I'd said something as a native speaker that sounds very strange. I'm violating a grammatical rule. Almost nobody formalizes the rule. Got something to do with the ordering of adjectives, right? The big red ball bounced down the street is the right way to put things. Now, I've been following this rule my entire life since I was very small. Nobody's ever taught it to me as far as I know. Do I have an internal representation of that grammatical rule?
I wouldn't want to say so. No, I was only describing what people think when they say that there are representations of grammatical rules. I think we have habits, and those habits can be inculcated by reinforcement learning and by other things, and I actually think that whether or not you are breaking a grammatical rule there or a mere social convention of language is a moot point. I mean, it's for all these things. I was told when I was at school that it was a grammatical rule in English that you should never split an infinitive. That is to say, you should never put an adverb in between the two parts of the infinitive. When they say in Star Trek, to boldly go where no man has gone before, that's actually a failing of English grammar. That's what I was told. In fact, it's not. It's a mere matter of style. Where those distinctions between style and grammar come from is a very interesting question, and much more interesting than saying that there must be grammatical rules in the brain.
So whatever we have going on, whether it's a rule or whether it's not in our brains, even if ChatGPT doesn't have what we have, if it has a rule and we don't, or if we do have a rule and it doesn't, we get to the same place in the end, right? We output the same kinds of sentences. Is this the kind of thing that we should be thinking about when we're assessing whether ChatGPT has artificial general intelligence, or does it really matter the internal structure when the output looks very similar?
That's a great question. I think yes. I think what matters to us is whether they perform cognitive tasks as well as humans do, and whether they're doing it the same way or a different way they're performing the cognitive task well in this kind of case.
If I were very, very sure that whatever ChatGPT is doing, it has nothing to do with intelligence, I could say something like, look, it's not a cognitive task. It's some kind of computer-y task. What I do is a cognitive task. What that thing does isn't cognitive.
Well, I'm with you on that, Audrey. Absolutely. Totally. I mean, I think you can call these things intelligent if you want. You can say that this is intelligent behavior. You can classify it even as generally intelligent or showing human-like intelligent. But it's not cognition. It's not thinking. So it matters hugely what the internal structure is. This ought to be the lesson from the collapse of behaviorism in psychology. Behaviorism, I should say, is the view that all that matters for psychology, for the application of our psychological concepts to an organism, is how it behaves or how it's disposed to behave. And how the thing works on the inside is not relevant to whether it's a psychological being or not. And I think that there's a lot of behaviorist thinking around AI. And if you think that the innards, the inside of the machine makes no difference to how, to whether the thing is really performing a cognitive task, as Audrey says, then that's basically a behaviorist line of thought. And I'm not just throwing an insult out here. That is behaviorism. The way these machines are trained, they're trained on enormous, huge amounts of data across vast data centers situated all over the world, communicating through the internet at the speed of light down a fiber optic cable, using these chips that are originally designed for video games to assemble vast amounts of information to, in the case of large language models, predict the next word with a high probability. Now, it matters hugely that that's the way it's done, to whether you think this is cognition or not. And this takes us on to another question, which is, what is cognition? So to me, the main thing is not whether we classify these things as intelligent or not. We can say that they're intelligent if you like, but the main question is, why would anyone think that this constitutes cognition or thinking?
I would like to get clearer about what thinking is in your view. So you might think that what AIs do is not cognition because it's not conscious. But it seems to me that humans do a whole lot of unconscious thinking. It's not clear that consciousness is required for intelligence or for cognition in any obvious way. Now, obviously, humans do sometimes have conscious thoughts, which are sometimes intelligent thoughts. But I think many of our thoughts, or much of our thinking, is at a subconscious or an unconscious level. So when I come up with the grammatical sentence, the big red ball, I never have to think which way round do I put the adjectives. And yet it sort of pops up in my head. And that strikes me as very similar to what an AI would be doing in a similar context. Why do you think that what humans do there is radically different from what AIs do?
totally agree with you that a lot of our mental life is unconscious. Maybe most of our mental life is unconscious, and that's generally agreed among psychologists and neuroscientists. But the fact that we do think consciously is deeply relevant to the nature of thinking. What we count as thinking, what we count as reasoning, is modelled on the conscious process of thinking and reasoning. This takes us into another question, which is what makes something an unconscious process of reasoning, and that's something it's a big issue in the philosophy of mind and neuroscience. But I think that we cannot just say the mere fact that we do things unconsciously gives reason to think that an unconscious thing like a computer could be thinking.
So we've spent a couple of minutes talking about these very theoretical questions, right, about consciousness and about what it is to think, what it is to be intelligent. I want to come back to something that Tim brought up earlier, which is a much more practical question. These theoretical questions seem to matter very much because they matter for evaluating whether there are actually things in the world with artificial general intelligence, or even if there aren't, whether there could be. There are a lot of companies right now who are very, very invested in talking about artificial general intelligence and saying, oh, we might be able to get to this in 5 years. Oh, actually, no, we might be able to get to this much, much sooner. What is the relationship between these theoretical questions and these practical ones about what companies can do and what products might be on the market in the future? What can philosophy do to help us answer these questions?
We may have similar views on this, I'm not sure, but I'm a bit cynical about this. I don't think it's a clearly scientific, purely research-based question whether there will be such a thing as AGI. It's also a marketing question. I think what the AI companies are trying to do is to try and sell us a vision of something which is not just a computer, that's going beyond what a computer is. Computer is an information processor, automated problem-solving machine. But they want to say, no, what we've discovered is something incredible. And they want to say two things which are in slight tension with each other. We don't really understand how they work. We've created this monster, and we don't know what's going to happen, and it could be uncontrollable. And by the way, the only people who could control it are us, because we're the only people who understand it. So these things are somewhat in tension. You get this from Geoffrey Hinton and others all the time. Geoffrey Hinton was one of the people who pioneered the software behind today's deep learning machines. Here's the thing. It's a computer. It's not a deadly virus. It's not a monster. It's a computer. And they want to tell us that this is going to be the most amazing thing that's going to transform the world. And they have to have words to describe that. So they invent this word, AGI. And once we have AGI, then we might have superintelligence, and then we have to control it. So you can't regulate us. And it's very, very important that they don't want to be regulated. And of course, the reality of the matter is that they're using huge amounts of energy, huge amounts of water. They are using up enormous number of rare earth metals to build these things. And they are investing massive amounts of money, hundreds of billions of dollars, in something which is not making a profit. So there's enormous risk here, but they're disguising the risk by saying that we're on the brink of this thing which is going to transform everyone's lives. So I'm very, very cynical about this, and I think we ought to tell the truth about what these machines really are.
I think we can agree on your being cynical about this. I think, of course, we should be alert to incentives in the market and to marketing speak and so on. And it's a largely empirical question, isn't it? How much computer technology can advance, how much AI technology can advance in the coming years and on what timescale and so on. It's partly a philosophical question, I think, because it's partly a conceptual question. What is intelligence in the first place? What could general intelligence be? How should we understand that? That's where philosophers have something to contribute. And it's great that Tim's thinking through this stuff at a deep level. I think philosophers should be wary, though, of making a priori arguments about whether things are or are not possible. We should be very careful about that. Philosophers have made mistakes in the past from the armchair, saying what must or must not be the case and been proven wrong in practice. So I do think we have a role to play, but we should be careful about that role.
Before we wrap up, I'll ask you each, for those listening who are not philosophers and who are not actively involved in the programming of potential artificial general intelligence agents, what might we take away from this conversation?
I would say be skeptical of marketing slogans masquerading as scientific predictions. Simon's right. We shouldn't speculate about how empirical things will go, but we can speculate about whether things make sense. And I think we need to be very, very skeptical about whether these predictions for superintelligence and things like this really make any sense.
I think that artificial intelligence is incredibly interesting, actually, and I'll go back to your comment, Audrey, that what the LLMs seem to be doing is very similar to what we seem to be doing. The kind of learning that you get with reinforcement learning is very similar to the learning that humans seem to have done as we grow up. It might be that our concept of intelligence itself is a rather anthropomorphic and maybe even a chauvinistic one. We measure the intelligence of other things against ourselves because that's how we are. And we may find that machines don't measure up to that level in some ways, even though they massively exceed it in other ways. And I think we should be reflective about what we think about intelligence in the light of that.
Thank you both for those thoughts. And thanks very much, Simon and Tim, for joining us here.
Thanks, Audrey.
Thanks, Audrey.
Thank you.
This podcast has received funding from the Austrian Science Fund as part of the Knowledge in Crisis project. We're a collaboration of more than 50 philosophers at the University of Graz, the University of Salzburg, the University of Vienna, and are led by Central European University. For more information about our research and details about upcoming public events, visit www.knowledgeincrisis.com. You can also find us on most social media platforms at Knowledge Crisis. Thanks for listening, and stay tuned for our next episode.